tension. So tension, as we've discussed a little bit before, is a force along the length of a medium. So that just means it's a method of transference. It's an object. All right, so this is usually a rope or a string. Okay, the word itself comes from a Latin word meaning to stretch. Okay, so hopefully that might make the connection for you that tension is always a pull. You can't push on a rope. Well, you can, you just won't get anywhere. So, is the tension constant throughout a rope? So, here's a picture of a mass hanging, all right, from a hook. Now, if we make the assumption, like we're normally going to, that the string or the rope has no mass of its own, then the forces acting on the block are only gravity and tension. So tension has to equal the weight of the block. All right, and so if you look at it from the other end at the hook, all right, you have essentially the normal force of the rope on the hook and then what the tension is going down. So in that case, it's not moving, it's at equilibrium, it's not accelerating. Therefore, the normal force from the hook has to equal the tension. And the tension equals the weight of the block at the bottom. So, yes, the tension is constant throughout. There's nowhere here where the tension could change. All right, what about this scenario? Same picture, but now we're giving this rope its own weight, okay? And the box at the bottom also has a weight, and it wants to know what's the tension in the rope. Well, if I'm looking at the bottom, all right, so I'm looking at, if I take a free body diagram of the box, the forces acting on it are gravity downwards and tension upward. Okay, so at that point, the tension equals the weight. The block is not accelerating, therefore the vertical forces must balance. All right, what about at the top of the rope? Now, the forces acting downwards are the weight of the box and the weight of the rope. And therefore, again, the top of the rope's not accelerating. The hook has to be applying an upward force equal to the combined weight, which in this case is 150 newtons at the top. But at the bottom, it was only the weight of the box. So here, the answer is E. This is the most complicated scenario you will get with a tension problem in AP Physics 1. Okay? And this only applies if the rope has a mass of its own. All right, so let's talk a little bit about pulleys, okay, because we use them in our lab, and they are frequently used in tension problems. Pulleys just change the direction of the string, okay, because for now we're going to make some assumptions, okay. For right now, we're going to assume that the pulleys are massless, okay, so it costs us nothing to rotate them, and there is no friction at the axle. Okay, so again, that has to deal with it not costing us any energy. The pulley is there merely as a device to change the direction of the string.